Hello dear students, in this video we are going to solve exercise 13.2 problem number 1 to 4. Let us move to the first question. Here we have a solid, okay, and the shape is a hemisphere at the bottom and a conical part is attached. Okay, and also it is given the diameter or radius of the hemisphere is equal to the radius of the cone, and that is equal to 1 centimeter. Okay, that is given. The radius of the hemisphere is same as the radius of the conical portion. Okay, and also the height of the cone is equal to the radius. Okay, that means the height of the cone can be taken as h, and that is equal to radius, and since radius is given as 1 centimeter, height of the cone also 1 centimeter. Okay, and we have to find out the volume of this solid shape, okay, in terms of pi. Okay, so as I told, we have to find out the volume of the cone plus volume of the hemisphere. That will give you the volume of the solid. Is it clear, children? Okay, so volume of the solid equal to volume of cone plus volume of hemisphere. Okay, learn the formula. Okay, that is the only thing you have to do. So what is volume of the cone by formula? That is 1/3 of volume of the cylinder, right? So that is 1 by 3 into pi r square h plus volume of hemisphere is half of volume of the sphere, and that is 2 by 3 pi r cube. Okay, and from these two terms, being radius are the same for both shapes, okay, you can take pi common and denominator 3, so pi by 3, and also r square, and from here r cube, so from the two terms you can take r square common. Okay, so pi by 3 r square can be taken outside. Okay, 3 are there in the denominator, pi and r square. So pi r square by 3. Okay, and in the bracket from the first term you can see h alone. Okay, pi r square by 3 we have taken outside, plus here pi r square by 3, so you will have 2r. R cube means r square into r. So r square already have taken outside. Okay, so in the next step we can substitute the values. Here the value of the radius is given as 1 centimeter. So pi, we have to get the answer, the volume of the solid in terms of pi. Okay, so we need not be substituted. Okay, we can keep the pi as it is, and being 1 radius 1 square by 3, and h also, the height of the cone is given is equal to the radius. Okay, so radius is 1 plus 2 into r1. Okay, so this is equal to pi into 1 square is 1, okay, by 3 into 1 plus r into 2 into 1 is 2. So 1 plus 2 is 3. Okay, so this 3 and 3 get cancelled, they are connected by into, so that you can reduce. Okay, so the answer is pi. Pi remains there, so the volume of the solid is pi centimeter cube. Volume always should express in cubic units. Okay, this is all about the first problem. In the second problem, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones are attached at both ends. Okay, that means here it is given the radius of the cone is equal to the radius of the cylindrical portion. Okay, with thin aluminium sheet. That means thickness is negligible. Okay, and the diameter of the cone as well as the cylindrical part are given as 3 centimeter, and the total height of the model is 12 centimeter. Okay, we have to find out the volume of air contained in the model. Question is clear, children? Okay, now we are moving to this solution. Okay, so here since we have given the radius both are same, okay, and diameter is 3, so its radius will be half of the diameter, that is 3 by 2. Okay, that means radius of the cone equal to radius of the cylinder. Okay, so we can represent by the same symbol, that is R. Since the diameter equal to 3, so 3 by 2 centimeter. Okay, and height of the cone is given as 2 centimeter. Okay, so here 2 centimeter and the height of the cone is 2 centimeter. Understood? That means this 2 and from this 2, okay, should be subtracted from the total length of the that is model, then only you will get the height of the cylindrical portion. That means being the height of cone and cylinder are different, we have to represent with a different notation. That is, we can represent the height of the cone as h1, okay, and both having the same. So, height of this cone is equal to height of this cone, and that is given as 2 centimeter. So, h1 equal to 2 centimeter. Okay, so the height of the cone, so I am representing with h1 and that is given as 2 centimeter each cone 2 centimeter. Okay, so what will be the height of the cylindrical part? That means that can be represented with the h2, and since the total height is 12 centimeter, okay, so from 12 you have to subtract the height of each cone, that is 2 from the top and 2 from the bottom. Okay, so 2 plus 2, that is 12 minus 4, and that is equal to 8 centimeter. That is height of the cylinder is h2 and that is 8 centimeter. Okay, now we are moving to the volume, that is volume of air contained in the model. Okay, so volume of air contained in the vessel or the model, okay, that is equal to volume of 2 cones, right? Okay, as I told in the beginning, we have to find out the volumes of each solid separately, okay, plus, okay, then volume of the cylinder, okay, volume of cylinder, okay. So, volume of 2 cones, what is the volume of 1 cone? 1/3 of volume of the cylinder, that is 1 by 3 pi r square h. 1 by 3 pi r square h. So, what will be the volume of 2 cones? 2 into 1 by 3 pi r square h. Plus, what is volume of cylinder? That is pi r square h. Pi r square h. Okay, but here the radius both having the same radius. Okay, we already represent with the r, but height both having different height. So we have taken volume of height of the cone h1. Okay, so h1 and height of the cylinder is h2. This step is clear, children? Okay, because the height of both the shapes are different, so we have to represent with the h1 and h2. So, in the next step I am going to take the common from the two terms, okay. So, pi and r square can be taken outside, because since r being same, pi r square and in the bracket, okay, 2 by 3, that is denominator 3, okay, h1 plus pi r square already taken outside, okay, then h2. Now, in the next step we can substitute the values, okay, that is pi you can substitute as 22 by 7, okay, and r square, r means 3 by 2, radius is diameter is 3 centimeters, so it's half, that is 3 by 2 into 3 by 2, okay, since r square, understood, and 2 by 3 into h1, h1 is height of the cone, that is 2 centimeter, plus h2, h2 is height of the cylinder, that is 8 centimeter. Okay, and this 2 in 22, 2 into 1 time 11 time. Okay, and 11 into 3 into 3 remains there. Okay, so 9 into 11, 99 divided by 7 into 2, that is 14 into, in the bracket, 2 into 2, numerators can be multiplied to 4 by 3 plus 8. Now we can solve the bracket first. Okay, this 4 by 3 plus 8, since the terms are connected by plus, we have to do cross multiplication. So 3 into 8 means 24. Okay, plus 4, that is 28, whole divided by 3. Clear, children? 3 into 8, 24, plus 3, 28 by 3. Okay, so that is the next step I am going to write over here. Okay, that is 28 divided by 3. By finding the cross multiplication, this bracket reduced into this form. Clear? Now, since they are connected by into, you can reduce. Okay, 14 in 28, 2 times. 14 in 14, 1 time, and its double is 28, so 2 times. Okay, and with 3 and 99, 3 in 3, 1 time. So 3 in 9, 3, and in 9, 3. So nothing is there in the denominator. So 1 ones are 1 itself. So in the numerator, 33 into 2, that is equal to 66 centimeter cube. This is the volume of air contained in the shape, that is model. Is it clear, children? Yes. In the third question, we have to find out the sugar syrup contained in 45 gulab jam. If 30% of the volume of 1 gulab jam is sugar syrup. Understood? That means you have to find out first how much sugar syrup contained in 1 gulab jam. Okay, and if you multiply that volume with 45, you will get the sugar syrup contained in 45 gulab jam. Is it clear, children? Okay, for that the shape of the gulab jam is a cylindrical part is in the middle and both ends hemispherical shape. Okay, and the total length of the gulab jam is 5 centimeter. Okay, and the diameter of both the cylindrical portion and the hemispherical portion are both are the same, and that is given as 2.8 centimeter. Okay, so our first task is to find out the volume of volume of 1 gulab jam. Okay, and after getting the volume of 1 gulab jam, okay, you have to find out the 30%, that is the sugar syrup contained in 1 gulab jam. Okay, so in order to get the volume of 1 gulab jam, that will be equal to the volume of cylinder plus volume of 2 hemispheres. Okay, and we can find out, we can take the 30% of that entire volume of 1 gulab jam, and that will be the amount of sugar syrup in 1 gulab jam. Okay, so since the diameter is given as 2.8, okay, so radius being both are the same, we can represent by r itself. So 2.8 divided by 2, and that is equal to 1/4 centimeter, 1.4 centimeter. Okay, and in volume of cylinder, and that is pi r square h. Okay, that means you have to find out the length of the cylinder, that is cylindrical part. Okay, and since here the diameter is 2.8 and this r radius is equal to the height, the depth, okay, the length of the hemisphere. So here 1.4 is the radius. So this 1.4 from this side and 1.4 from the another end should be subtracted from this 5 centimeter, that is total length. Okay, then that the remaining length will be the height of the cylindrical portion. That means this length and this length being equal to the radius, that is 1.4. that should be subtracted from the total length, that is 5 centimeter. That will be the height. Okay. So height of the cylinder, okay, length of both are the same, of cylinder, okay, h. Okay, we don't have h in the formula of volume of hemisphere, so we can represent with h itself. No need to write in terms of h1, h2, that is not needed for this problem. Okay, h is equal to 5 minus of, okay, this is 1.4, that is the radius, that is equal to 1.4, plus, and other side also radius is equal to 1.4. That means 5 minus 1.4 plus 1.4 is 2.8. 2.8. Then we can subtract 5 minus 2.8, that is 5, 2.8. Okay, borrowing 2, 2 for 2, that is 2.2 centimeter is the height of the cylinder. Okay, now we can write the volume of 1 gulab jam. Okay, that is equal to volume of 2 hemisphere. So, what is the volume of 1 hemisphere? 2 by 3 pi r cube and 2. So, 2 into 2 by 3 pi r cube, okay, plus, and cylinder, that is pi r square h, pi r square h. So, this is the volume of 1 gulab jam. Okay. So, from these two terms I am going to take pi r square common. So, pi r square into, okay, 2 into 2, 4 by 3. So, r square means, r cube means r square into r. So, one more r is there in the first term, plus h. I have taken pi r square outside. So, 4 by 3 r plus h. Okay, what is this? This is the volume of 1 gulab jam. Okay, and what is asked? Sugar syrup contained in 45. So, we have to find out how much sugar contains in 1 gulab jam, and that is given as 30% of volume of 1 gulab jam. 30% means you have to multiply this with 30 by 100. How to convert percentage into fraction? 30 by 100. Okay, that is 30 by 100, okay, into pi r square into 4 by 3 r plus h. What is this? This is the volume of sugar in 1 gulab jam. That means 30% of volume of 1 gulab jam. But we need 45. Okay, so you have to multiply this with 45. In order to get the volume of 45 gulab jam, you have to multiply this with 45. So, 45 into this 30 by 100, can we write this as 0.3? Shift to the left side by 2 places because we are dividing with 100. 0.3. Okay, and pi 22 by 7, and what is r square? Okay, what is r? R we have seen that here the diameter is 2.8, so 1.4. So 1.4 into 1.4 for r square, and in bracket 4 by 3 into 1.4 plus, and height means the height of the cylindrical portion, and that we have seen that 2.2. Okay, we subtracted 2.8 from 5 and we have seen that is 2.2. Okay, that is the next calculation. Okay, I am going to rub this. Okay, so children, here I am keeping this 45 into 0.3. Okay, and we can reduce this 7 in 1.4. 7 in 14, 2. So, in 1.4 we have to take the number from the decimal place. So, you have to keep decimal, that is 0.2. Okay, so into 22 into 0.2, 7 in 1.4, 0.2, and one more 1.4 into, okay, Here 4 into 1.4, that is 14 into 4, that is 56, right? 4 4s are 16, 1 carries, then 5. Okay, and 1 decimal point divided by 3 plus 2.2, this one. Okay, and since they are connected by plus, we have to do cross multiplication. So 3 into 2.2, that is 22 into 3, that is 66. So 1 places. So 6.6 by 3. So here I am writing 6.6 by multiplying 3 into 2.2 whole divided by 3. I hope this step is clear. Okay, in the next step we can add these two, that is 5.6 and 6.6. 2, 1 carries, 11 plus 12.2 divided by 3. Okay, you can multiply this 2 and 45. That is 45 into 2 is 90. So 1 place, so 9. So we multiplied 45 and 0.2. Then 0.3, this 0.3. And for 22 into 14, this 22 and 1.4. So 22 into 14, that is 8. Then 2 and 8, 0, 1 carry, 308. So 1 decimal place. Okay, that is 30.8. Okay, and here these two terms together 12.2. Okay, divided by 3. Is it clear? This is 12.2 we have seen already, and this denominator. Okay, see children, here 0.3 and 3. Okay, so 3 in 3 one time, so 0.1. 0.3 and 3 get cancelled, so there is 0.1. Then the final multiplication, that is 9 into 1, 9. So 0.9 into, okay, 308 into 122. Okay, so we are getting the volume of 45 gulab jam directly. If you are doing like this, this would be better children. Okay, that means 308 into 120. Find out the product without the decimal point. Okay, 16 and 6. Okay, 16, 6, 8, 0, 3. So 6, 7, 9, 15, 1 carry, 7, 3. So 1 and 2, 2 decimal places. So 375.76. This should be multiplied with 9. Okay, that means 54, 5 carries, 63, 5, 68, 6 carry. Okay, 45, 6 and 51, 5 carry. Okay, and here it is 63, 68, 6 carries. Okay, 27 and 6, that is 33. Okay, altogether how many decimal places? Here 2 and 0.9. So 1, 2, 3. That is 338.184 centimeter cube. This is the volume of sugar syrup contained in 45 gulab jam. Since the decimal point is just a 1.184, that can be neglected. Okay, it is very less amount. So 338, okay, centimeter cube approximation. Okay, this is the volume of sugar contained in 45 gulab jam. Okay, so first find out the volume of 1 gulab jam, right? Okay, then find out the sugar syrup in 1 gulab jam, that is given as 30%. Okay, so 30% means 30 by 100 of the volume of 1 gulab jam. Okay, then multiply with 45. Okay, that will give you the sugar syrup altogether for 45 gulab jam. Okay. In the fourth problem, we have given a pen stand of wood, okay, having 4 conical depressions. Okay, and the dimensions of the cuboidal pen stand, that is length is equal to 15 centimeter, this is the breadth 10 centimeter and height is 3.5 centimeter, that is given. Okay, so from the wood, that is from the cuboidal pen stand, that there are 4 conical depressions. Okay, that means you have to make 4 conical depressions over there. That means that much wood should be taken out from the cuboidal wood stand. Okay, and what is finally asked? What is the volume of wood in the entire wood pen stand? That means you have to subtract the volume of 4 conical depressions, okay, from the volume of the cuboidal pen stand. Okay, and for that the volume, that is L, B, H are given, length, breadth and height is given, and also see this is the conical depression, okay, and its height is given as 1.4 centimeter. Okay, the height of the depression, depth of the depression, okay, and the radius is given as 0.5 centimeter. So what is the volume of cone? Pi 1 by 3 pi r square h. So r and h are given, okay, and multiply that with 4 and you will have the volume of 4 conical depression. Okay, that should be subtracted from the entire cuboidal wood stand. That will give you the wood in the stand, okay, that pen stand. That is what we are going to do. Okay, so volume of wood, okay, volume of wood in the entire stand equal to volume of cuboid minus 4 into, we have 4 conical depressions, and what is the volume of one cone? That is 1 by 3 pi r square h. Here one more thing should be noted, we have height of the, what is it, dimension, there you can see the height of the cuboid is given, and also cone, the depression, that height of the depression also given. So both are different. So we can give this height as h1 and the depression, that is height of the depression as h2. Okay, so you can write the formula, that is volume of cuboid is L into B into H. So H1, so 4 times 1 by 3 pi r square H2, since both height are different. Okay, we have to represent in different way. Okay, so we are going to substitute for L as 15, that is given, breadth is 10 and H1 is 3.5 minus 4 by 3 into 22 by 7 into, okay, r square, that is this r is radius, okay, radius of the conical depression, that is given as 0. I am going to rub this, okay, that is given as 0.5, okay, radius of the conical depression 0.5 into 0.5 and H2 is 1.4. Okay children, so we are going to multiply, see since we have 10 into 3.5 means 35, shift the decimal point to the right side, so 35, so 15 into this together 35 minus, okay, and how this can be done? Here 4 in, we can't reduce because all are co-prime numbers, we can reduce, no common factors between them. So 4 into 22, that is 88, divided, here 7 in 1.5, sorry 1.4, that is 0.2. Is it clear? Okay, now 0.5 into 0.5, that is 5 into 5, 25, that is 0.25, 0.25 into 0.2 divided by this 3. Okay, this 7 get cancelled in 1.4 in 0.2 times, that is the 0.2 I have written over there. Okay, and here 0.25 into 2, 25 into 2, that is 50, 25 into 2 is 50, okay, and there are 3 decimal places. Okay, 0.25 and 0.2. So you have to keep 0 and 0.050. Hope this step is clear, children. 0.5 into 0.5 into 0.2 is 0.050 and divided by 3. Okay, and what will be here? 15 into 35. That is 5 into 5, 25, 2 carries 15 and 5, 20, 22 and 2 carries 5, 1 3s are 3 plus 2, 5, 25 minus, okay, here we are multiplying 88 into 50. Okay, that means 88 into 5, that means 44 carries and 40, 44 and this 0. And we have 3 decimal places, 1, 2, 3, that is 4.4. Okay, since we have 3 decimal places, that should be shifted to left side. So you will have 4.4 divided by this 3. Okay, so 525 minus 4.4 divided by 3. That is what we are going to divide over here, divided by 3. 3 in 4 one time, okay, then 14. So decimal place, so 4 times 12, okay, remainder 2. So in 20, 6 times, okay, again 18, remainder you are getting 2. So it will continue because we have learned that is if 3 comes and if numerator not a multiple of 3, it will not terminate, division will not terminate. So we have to round off to 2 decimal places, okay. So it will go on, so 666. So 1.4666 etc. So we can round off to 2 decimal places. So in the third decimal place, 5 or more than 5, we can add 1 with the second decimal place. So this will become 1.47. 1 should be added with this 100th place. That is 1.47. That is 525 minus 1.47. Okay, now we are moving to subtraction, that is 1.47 should be subtracted from 525. Okay, that is 525 minus 1.47. Okay, so borrowing you will have 3, so 9, 5. Okay, so 3, 2, 5. That is 523.53, being it is volume centimeter cube. This is the volume of the entire pen stand. Okay, after subtracting the volume of 4 conical depressions, we will have 523.53. This is all about the 4th problem. Thank you for watching and supporting my videos. Thank you all.